Now that we've learned the nuts and bolts of adding and subtracting fractions, I'm going to do a few examples that have some more complicated elements that are typically confusing to kids. The first is 2m over 2m minus 1, and I'm going to add that to 1 over 1 minus 2m. So the first thing I want to do is put my polynomials in parentheses and then look for a common denominator. It may at first glance appear that this denominator has no common factor with this one, which is true. However, these two are related. They're opposites of each other. Any number I plug in for m, let's say I plug in 3. 2 times 3 minus 1. 1 minus 2 times 3. This one gives me 5. This one gives me negative 5. No matter what number I plug in for m, those two expressions are opposites of each other. Therefore, if I say I'm going to take the opposite of this, I can switch the order. Mechanically, what that boils down to is I've got 2m over 2m minus 1. If I change this sign to subtraction, I then can change the order of this, 2m minus 1, which makes this a very easy problem. It simplifies to 2m minus 1 over 2m minus 1, and that, as we know, equals 1. I could go through the whole thing of, this is missing 2m minus 1, this is missing 1 minus 2m, but the math becomes dauntingly complex, and you're likely to make mistakes. So better just to do this. The next problem I want to do has that element as well as others. The problem is a over ab minus b squared, and it's plus b over ab minus a squared. I put my polynomials in parentheses and then factor the denominators to see what the common denominator should be. This is a common factor of b, leaving a minus b. This is a common factor of a, leaving b minus a. Note, once again, these are not exactly the same, but they are related. So I can change this to a subtraction sign. I could take the opposite of it and switch the order, which accomplishes getting a common denominator, at least the first step toward a common denominator, quite niftily. We are still missing an a here, as well as a b here. So now I have a squared minus b squared over ab times a minus b. I think you will probably notice that this is a difference of squares. Therefore, it can be factored and needs to be factored. And now, because this entire number is the same, we can cancel, and the answer is a plus b over ab. Finally, the final level of abstraction, which I want you to understand, but I don't think I will ask you to execute on a test. X minus 11 over x squared minus 9 minus x minus 7 over x squared minus 3x. In the interest of space, I'm going to factor the denominators, hopefully quite small. X plus 3, x minus 3, and this one is x times x minus 3. You can see at this point that this is missing an x, and this is missing an x plus 3, which we don't have a lot of room for. And I'm going to put it here. If I draw my big fraction bar at this point, what I have is x times x minus 11. And this is x. Actually, I'm not even going to draw the big fraction bar just yet. And this is x times x plus 3 times x minus 3. And I need to subtract the fraction that has x plus 3 times x minus 7 as a numerator. And this is x times x minus 3 times x plus 3. Because I'm subtracting this entire polynomial, before I even, before I go to my big fraction bar, I want to FOIL. This gives me x squared minus 4x minus 21. And the reason why that's important is because on my big fraction bar, I need to make sure that that entire polynomial is subtracted. And it's important because since that subtraction, that -1 gets distributed over all of these terms, which changes their signs. So doing the math, I get x squared minus 11x minus x squared plus 4x plus 21 over x times x plus 3 times x minus 3. You can see that these are going to cancel out, and that leaves negative 7x, because I'm combining these, plus 21 over x times x plus 3 times x minus 3. And I'm going to go to the next screen to show you the final step, which is always to remember to factor and reduce. When I do that, I factor out a 7, and I get, where am I? I get x minus 3. No, if I factor out a -7, I get x minus 3. And that is over x times x plus 3 times x minus 3. And in the end, the answer is -7 over x times x plus 3. Again, that's really complicated, but just remember, when you have the trinomial, you need to FOIL first and then subtract. Adding on to these ideas is the notion of mixed expressions, which in the end ends up being exactly the same thing. Mixed expressions just means mixed numbers. 2 3/4. Well, you know from your arithmetic days that you're going to say 4 times 2 plus 3 over 4. And the reason we do that is because there are 8 quarters in 2 wholes. This is 8/4 plus 3/4 is equal to 11/4. Another way of thinking about this is just to say it's 2 plus 3/4. And we can do our old put it over 1, and what's missing? It's missing a 4. It's missing a 4. So that gives me 8 plus 3 over 4, which is 11/4. Either way, I get this answer. I will say this is the method that is going to correspond most easily with the problems that you need to do with algebra. This one is a relatively simple one. If I say c plus 5 over c, I could say c squared plus 5 over c, but I'm going to go through just putting this over 1. This is missing c, so it is c squared plus 5 over c. Not quite so simple when subtraction and polynomials are involved. I want to make this have a denominator of 1. Clearly, it's missing x plus 2, and I have to, in the space I have, do that. So I'm going to draw my big fraction bar, and I'm going to say this is 5 times x plus 2 minus, and remember, when I'm doing subtraction, it's very important to include parentheses, minus x minus 3 over the denominator of x plus 2. And just a reminder, I cannot cancel the x plus 2's at this point because of this spare negative minus sign that's not a part of a polynomial. Instead, I will simplify. 5x plus 10 minus x plus 3 over x plus 2. And that gives me 4x plus 13 over x plus 2. Again, those are all complete polynomials. There's no way to simplify and reduce, so we just... In its full glory, these problems look like x plus 5x plus 2 over x minus 1 minus 7 over x minus 1. Clearly, if this denominator is over 1, it's missing x minus 1. And when I draw my big fraction bar, I get x times x minus 1 plus 5x plus 2 minus 7 over x minus 1. Getting rid of parentheses, x squared minus x plus 5x plus 2 minus 7 over x minus 1. Combining like terms, x squared plus 4x minus 5 over x minus 1. I can't cancel parts, but I can factor the numerator and then see what happens. So I know I'm going to have x and x. My signs are going to be different. I'm looking for numbers that multiply to 5 and subtract to 4. They are 5 and 1. 5 goes with the positive, 1 goes with the negative, and lo and behold, there we are.